This question is from section 1.8a, I believe it's number 2, and we're looking at solving a system of two variables and two equations. There are three techniques for this. There's the graphing technique, the substitution method, and the elimination method. This example is going to deal with the graphing technique. If I want to solve a system, I first want to graph the two equations. I'm going to enlarge this graph, and that's going to allow me to click on the line tool and graph each equation. They're in slope-intercept form, so I can grab the y-intercept of the first line is 2, so I can click on 2, and then my line's going to immediately start tracing along my cursor, and I look back over here at the slope, it's negative 1/2, so from the point I clicked, I will count down for negative, down 1, over 2, and then click again. If you misclick, you can always move your point by clicking on it and dragging it, but I should be able to count down 1 over 2 for that negative 1/2 slope. Next, we're going to grab the line tool again, and then we're going to look at the y-intercept for the next line. It's at 7, so 7 should be right here. This one has a positive slope of 1/3, so from that point where you clicked, we'll count up 1 and over 3 before we click again, and now we can see that this line has y-intercept 7, slope up 1 over 3. Okay. Remember to save, and you can see your graph right here. Now I'm going to check answer on my graph. Excellent. And now I get to continue answering the question. What I'm looking for is the solution, which is the place where these two lines cross. If I make this bigger, I can see that the lines are crossing at the ordered pair -6 for x, comma, 5 for y. So there is a solution to this system. It is -6, comma, 5 as an ordered pair. All right. Now, if this question is finished, I want to talk about these other two options right here. If you had a system that was dependent, a dependent system would be a system where the two lines that were printed here were actually the same line. So they might not have been the same format, one of them might not have been simplified, but when you graphed both of them, you only got to see one line because they were the exact same line. That's the case where the system is dependent, and so the solution would be all points on the line, whatever it happened to be, because both lines were really the same. Okay. The final answer is inconsistent. A system is going to be inconsistent if there were two lines up here, and when you graphed them, they did not cross. They were parallel. If parallel lines are showing up in your graph, you're going to choose inconsistent. The solution set is empty. There's no place where they cross. One line, both lines being the same line, they're going to cross everywhere, so all points in the line are going to be solutions, but parallel will be no solutions. In many cases, you have intersecting lines, and you're going to choose the first option for intersecting lines and type in the ordered pair.